Hello teacher and hello everyone that watching this video. We are from Team A and today we're here to have a presentation on our automata project, a robot navigation simulator that is driven entirely by a deterministic finite automaton. And here is our member. We have 5 members, include me, my name is Megra, we have Mani, Raspiri, Usapir, and Ensing. And here is our content. We include 5 main points. And the first one is introduction, which is presented by me. So our main goal for this project was to take the theoretical ideas we've been learning in our automata theory class and bring them to life. We wanted to design a clean, formal command language that a robot could understand and then build a visual web app to prove exactly how a DFA handles string and process state transition step by step. To give you a quick overview of our robot's world, it moves around on a bounded 8x8 grid. It always starts out at the very bottom left corner at coordinate 0, 0, and it's facing north. The robot begins with a maximum energy level of 3 units. Every time it takes a physical step forward or backward, it consumes exactly 1 unit of energy. If that battery level drops to 0, the robot completely locks up and can't make any more move unless it recharges. And that's all for my part. Now I'll pass it over to Osupir, who will present about the language alphabet and our group-specific rules.
Thank you so much, Mekara. My name is Uspe and I'm going to talk about the next part, the alphabet. To assist with the navigation of our little robot, we divided the command into 3 categories. The navigation command consists of going forward, backward, or turning left or right. Left or right. The operation command consists of picking up an item and dropping the item. The life cycle commands consist of starting, or recharging. Next, we'll talk about the system rule. Rule 1. The sequence must start with the start command and end with the stop command. The second rule, the robot must perform at least 1 movement, going forward or backward. The third command, the robot must pick an item before dropping an item, and it cannot pick an item twice before dropping once. The fourth rule, movement costs energy. Going forward or backward costs 1 energy. Recharging resets the battery to full capacity. We have 3 additional rules. Rule number 8. The robot must complete at least 2 pick or drop tasks. Rule number 10. The robot cannot turn twice in a row. For example, going left and left or right and right. It can also not go in directions such as turning left and right and left. The 14th rule mandates that the absolute difference between the left and right turn can never exceed 2 at any single point. And that is all for my part, and I'll pass the next part to Superi.
Thank you, Usapir, and greeting to teacher. My name is Superi. Now I will show you about the DFS stat variable. In this point, the main call in our project was the stat explosion problem. The drawing a traditional DFA graph with explicit stat would result in thousands of steps. So to solve this, we model our DFA as a Cartesian product of bounded variables. The system tracks energy from 0 to 3 and carry status as a yes or no, last turn history, and turn balance bound strictly between -2 and -2 and +2 every position in our. All decisions are controlled by the rule check in code. For example, F will only execute if energy is available and the target remains within the A grid. Otherwise, the input is rejected. Then Insane will explain the system, architecture, and code into.
Very and hello teacher as everyone. My name is Ransay. For my part of the presentation, I will be walking you through the starting with the architecture and as a UI and UI design of our robot navigation simulator. the starting we are starting with the decision to build this the application internally using the web technology like HTML, CSS, and JavaScript. We intentionally avoid the heavy framework to ensure the simulator is lightweight, fast, and sticky. Focus on the logic. As you can see the slide, we divided our system into four main. The first is the constant as a moment. Is to store our foundation data and handle the direction grid map. Can we build the engine validation system automaton as our batch validator. When a user type a full sequence of command detention walk through the whole sequence and collect all the error that one. The third is our line validator. It is used exclusively by the manually control page to validate one single command at a time, strictly preventing the robot from ever making the error mode. Or the one not is the renderer and man handle all front DOM. The slide is a UI design. We want to make the infinity automaton, the internal state completely visible and interactive. On the left we have the menu drive pedal page. We implement smart bottom that talk directly to our live validator to ensure our current legal command are acceptable. For instance, if you turn left, both turn bottom and instant this is bought to enforce that the rule the again consecutive turn on in the center. In the center is our egg egg create visual grid where physical cell are thin blue so that you can easily detect the robot path. The right below that we build the compression shield robot state dashboard. This app that the real time allow you to monitor the robot coordinate first direction, remaining the energy and complete pick drop task as the automaton switch from state to state. Now my point has in, so I flow to the money.
After my friend presentation now, I want to remind you why we build and why it is a finite automation. The robot understands 9 commands: start, stop, forward, backward, left, right, pick, drop, and retract. A valid sequence of this command from a formal language, and a finite automation is the machine that decides whether a sequence belongs to that language. Our automation unfolds the rule. The rule number 1, start. The first step is start, and the last step is stop. If don't have start, the robot not run. And the last step not stop, it also, so it accepts step 1. Rule 2, at least one movement, not move to at the same road at the one time. Example, go is the same way. Now, the robot is not run. It accepts rule 2. Rule 3, pick before drop, and no pick tweak without dropping. So the robot cannot pick the ball box before it drop one. Now I will click run, it not run. It accepts rule 3. movement need energy, we check for it. If we don't have energy at this, the robot is not work. Now the energy is zero. It not work. It accept rule 6. Rule 8, at least 2 complete pick drop tasks. This override rule 4. So the robot need to at least complete 2 tasks completely that it can stop. And the robot pick and do on one object and I click run. The robot might completely 2 pick drop tasks. It accept rule 8. Now rule 10. No 2 turn in a row. This is override rule 5. And I clear it and I pass it and I click auto run. Now the robot cannot run quick in a row. So it accepts rule 10. Now the last rule is 14. The difference between left and right turn never exceeds 2. I replace this O to a U step and I click run. Now it accepts the rule 14 that cannot go to the same road flow into pole. So the robot need to different left and right. It's the last check that robot can pick object not inside the object position. Now I am disappointed with this and I click run. That not work. When I click auto run, the robot will process by our step that we set at upper. Now we can see the robot is following our rule and following cover our rule that we set. Now my path is at all for debug code. Thank you, teacher.